friends. So in this programming interview question, so I have a very interesting question for you. So it's like a puzzle. And what's the puzzle like? So the puzzle is that you are given a n cross n matrix or a cell. So let's see it pictorially. So this is, let's say, a maze to make it interesting. And here what happens that you have to go from this corner to this corner. And how? So we represent the cells where we can go is I represent it by 1, and where I cannot move I represent it by a 0. So if I start here, so in the maze you have to find a path from the top left corner to the bottom right corner. And what happens that you can only move towards the cell that are having a value 1. If they are having a value 0, then you cannot move to that cell. And of course when you are at some cell, so you can move to the right, you can move up, you can move left, and you can move down. Okay, so let's represent it by a matrix, let's say maze M, and I have n cross n maze. And what happens, each of the m I j is equal to either 0 or 1. So this is the thing, you can move towards 1 value cells, but you cannot move towards a 0 value cell. And the thing is, so if I start from here, so let's see, so if I start from here, so I am here, so this is fine, I try the right thing, I go there again. So let's try out in, I will go right and down. Okay, so I go towards the right, I see that okay there is a 1, I will go there, I again go right, I think I see there a 1, so it's fine. Then I again try first right, so right now I get a 0, so this one is wrong. So I now try down and I can go here, so I come to this place, then again I am at this place, so I will try right, so I can go to the right because there is a 1, so I come here. And then what happens, I'm here, so now I again try right, I cannot move there, so this is not possible. I go here downwards, so it's possible, I come here again, I try to move towards right first, it's not possible. I go down, it's possible, I come here, then I try first the right, it is possible, I come here, I cannot go towards any right now, I try down and I come here. So this is the path, so this is the path of my from going from top left to bottom right. And this is the thing that you have to solve using a computer program. So let's see how to do it. So first, very important, what are the approaches? So when you go to an interview, you cannot directly solve such difficult questions. So the interviewers will ask you that okay, you can, whatever you are thinking, you can say it loud, so think aloud. So that's what they will tell, so you have to think aloud. So this is a big buzzword, think aloud. Okay, this is not a trivial question you can answer directly, start writing the code for this one. So think aloud. Okay, so now what to do? So what we will do, one thing, if I start from here, so I have the 4 moves, up, down, right and left. These are the only position I can move. So this is my first, I will answer first that okay, I can start from somewhere, I don't try to write the code first, I try to think it. And I say that okay, my first step will be, I can go, if I am at this place, let's say, I can go up, I can go down, I can go towards the right, I can go to the left, I can move. So these are my possible choices. But are all these possible choices always there? No, it's not there. Why? If I am at this place, so 0, I cannot go to the right, I cannot go to the up, because why? They are 0, so you cannot go there. only ways you can go is towards the left and down. Okay, so this is one thing I find, that okay, I have to check something like, is it possible, is safe, or is it possible to go to some position from I and J. So I have some I and J, now I want to go to some other position. Is it safe? And what do you need to find out? You need this matrix Mn cross n to find. If it is 0, you cannot go there. So next what? So, and one thing more is, if I am at position I comma j, so moving up means what? I minus 1, I is the row, so I minus 1 comma j is up, I plus 1 comma j is down, I minus 1 comma, so I comma j minus 1 is left, and I plus 1, I comma j plus 1 is right. So these are the things that you have to understand. And now what happens if I am at somewhere? What are the things I have to see to decide if I can go there? So one thing is, when I am moving to whatever location, let's say I dash j dash, so m I dash j dash should not be 0, should not be equal to 0. So this is one thing. Then what are the other things? Then they should be in the limit, like I should be greater than equal to 0, because I am starting at 0, and I should be less than n, and similarly with j. So let's write, I think so we have to make a function to decide if I can go to that cell and I can see the movement. So now I have to see, is it possible? So this is the first function I write, which we discussed. Boolean is safe. Is it safe? So what we need, the argument mn cross n, which is the two-dimensional matrix of zeros and 1 telling which are possible cells, and int I, int j, where I am right now, where I want to go. So I say that okay, so if I is greater than equal to 0, so it means what? I can move there, okay, and if I is less than n, and similarly what? So j should be greater than equal to 0 and j should be less than n, and mij should be equal to 1. Then it is possible I return 1, otherwise 0. Then what? So let's see. So now we have a utility function. So I have to solve now the maze problem. Okay, so let's see what I have to do. So I will have to pass the mn cross n matrix, and then what I will do, I will have a utility function which says that okay, what is the solution like. So this is the solution matrix which has all zeros initially, but I will try to put ones whichever way we have traveled. Okay, so I have a solution matrix of n cross n. I call solve maze util. I give the m matrix, which is the maze matrix. I start from 0, 0, which is the top left corner, and I give the solution matrix to write the solution there. And what is the solve maze util function? Let's see. So this solve maze util has the m matrix, the maze matrix, which is 0, 1s, which says which are allowed cells, which are not allowed cells, int x comma int y, where I am right now, and int solution, which says that okay, print, write all the paths which I have traveled, write all the cells. So what happens? So it is a recursive function. I know that I will be calling myself again and again to see if I have reached the path. So if x and y, if I am traveling, and if I see that I have already, so if there is recursion, okay, so we have to see some of the things and concepts. If there is recursion, so there should be a base case where I say that okay, now recursion should stop because I have reached the goal. And what is the goal here? It is that I reach the bottom right corner. So I say that if x is equal to n minus 1 and y is equal to n minus 1, I am done, and I write okay the solution. In that I say that I have now solution n minus 1 is equal to 1, I have reached, I return true. So this is the final case. I am saying that I am done. But otherwise, what if I am in somewhere in between, I am searching for the path. So if I try now, if is safe, so I am here, I am trying this new cell. So I say that is it safe, m x comma y, and if it is safe, and how we calculate safe with this function, I am trying to go to cell I comma j. Is it safe? If it is, then I write that okay, I am traveling this, so I put solution x comma y is equal to 1. So I am traveling this for now. Okay, at least now I know I am trying some path, and I say that okay, it is possible. And then what I do, so I have come here, and next I have to go somewhere else. So I try first, what I try, if I am at x and y, then I go try the rightmost cell, because I am moving towards the right and bottom. So I move towards the right first, this is right, and I call this function again solve maze util. M is the same because that matrix is same, but now I am moving towards the right cell. I increment x plus 1 I do. So I am moving down first, so this is down because I am doing a x plus 1. So I am moving down first, trying a down cell, and y is the same, column is the same, and I pass the solution to be written. And then what I do, if say let's say that I try this one and it goes to x plus 1 comma y, and I see that okay, it's not safe to go there, I come back here, it comes back. Okay, so it comes back. If it is this solve maze util is not, if it is true, then I return true, but if it is not true, then what, I go to this line and I call if solve maze util m x comma y plus 1. So I go to a right cell because it is x is same, y has incremented, so it's a right cell, and I say that okay, solve maze util, if it is towards the right, if it is possible, then go there. But if that is also not possible, I try to move towards the right, I try to move towards bottom, both are not possible, then whatever cell I had come to, so that is a blocking cell, I cannot move anywhere from there. So I write that okay, I backtrack from there and say solution x comma y is 0. I had said that okay, it is 1, but now I see that I can neither move down nor to the right, so this is not a good path to travel, and I come back that okay, the path is closed, I should come back and try some other path. So I put solution, and this is the most important step here. It is the part of backtracking. Okay, this is called backtracking. What we do in life also, so I don't know, I have to go from some location x to y, I try some different directions, but when I come to some point from where I cannot move anywhere, so I go back and try some other path. So here also I cannot move towards the right because it is not safe, I cannot move towards bottom because it's not safe, so I cannot move at all. So what should I do? I should backtrack. So this is an algorithm of real life, and I backtrack and go back and return false. So I now go somewhere else and try some new path. Okay, so if say I had tried the right path here or the down one, and if I backtrack because there was no path, so I will try this right path. Okay, so this is the case. And now what we do, so we do this thing, and if there is a possible path, we print that path, it will make all those things 1. But if there is no path, so what will happen, it will make the path as 0. So now let's try to see one example. Okay, So we will see one example here, and it will be, let's say we are doing a backtracking algorithm. Okay, so let's make a small example. Okay, let's make a small example of 4 cross 4 cell. Okay, so it's the 4 cross 4 cell I'm making, and now let's make some. So it is 1 here, 1 0 1, and then I put 0 1 1 0 1 0 1. Okay, so let's try this example. 0 0 1 0 1. Okay, so this is the matrix and I want to move now. Okay, so what I do, so I call this solve maze, and I give matrix and then 0 comma 0 from where I want to start and solution. Okay, so now let's see how this algorithm works. So I'm here at this place, and then what I do, I now see that okay, if x is equal to n minus 1, where n is 4 now, so if we are at x 3 comma 3, then we are done, but it is not so now. So is safe mx comma y, so 0 comma 0 is safe, so I write that okay, solution 0 comma 0 is 1. Then what I do, I solve maze util, I try to first go down. Okay, so I first try to go down, so I come here, so again I check if is it safe, so I see that it is greater than 0, equal to 0, so this is boundary is good, and mxy is 1, so I can come here. So now in the solution matrix, let's make a solution matrix also. So it is, initially it was all zeros, let's say I don't put anything, so now I put this as 1 because it was in the solution, and this is in the solution. So now what happens, let's say now again I'm here, and I now try what, again a down. So when I go down from here, so I find what, mxy is 0, so it is not safe. So what I do, so what happens here, you can see in the code. So now I come here and I see m is safe, mxy is false. So what I do, I just return a false. So I return a false and try now right, and I see that here this is 1, so I can come here, and then what, it is safe. And now what I do, I try now again a down, and down also is safe because here this I is now 2 and j is 1, so it is safe in the boundary, and mxy is 1. So I come here, and now what I do, I again now call solve maze util with this down, but I see that this is not safe because this is 0 here, mxy is 0. So now what happens, so this code was here, so it comes with towards the down coordinates. This is not now 3 comma 3, so this code is not executed. So it comes, is it safe, so this is not safe, so it directly goes to return false. So now it returns false, so it tries the right path, so this is true here. So now what it does, it tries a down is also fine, and then it tries another down, but now x becomes 4, which is not in the boundary, so it goes to the right and it finds it is correct. So this is the way this recursive function works. So this we saw about recursion, but one thing in this example we could not see was backtracking. So how does backtracking work? Okay, so let's try one example. In this one only, try to change. So here just in this matrix the solution matrix will be 1 1 1 1. So when would we have backtracked? So let's say that here this was also a 0. Okay, so let's try to rub a few things. Okay, and let's put here a 0. Okay, and what we need to do, I put a 1 here. So now what we need to understand is backtracking. So till here I could come, and then what happened? Because what happens now, I am here, it is safe, I try down, I can come here, then again I try down, I could not go there, I try right, I could come here, again I tried a down, I could go here, then again I tried a down, I could not go there, then again I tried a right, I could not go there. What will happen now? So this is where the backtracking happens. So I tried if solve maze util down, so this return this was false, so it came out. If solve maze util right, this was also false, it came here. Then I say what? Solution x comma y is 0. So I am not going there, and I return a false. So I say that okay, so now what I do, I had traveled till here, and then what happens now? But I see that okay, from here I can neither move here nor here, so I cannot go anywhere from here. So I discard this place, I put a 0 here, this is not my path. I go back here, I had tried the down one, I try the right one, another path, I try from here. So this one I go to here, I try right, and now what happens? Okay, so we have to change the matrix. In fact, if we are here, what happens now? I come to this place, and here it is fine, but I try down, it is not possible, right is not possible. And then what happens if this is the case? So at this place I have exhausted this, so I will return false, and there is no path possible. But if it was 1, this was 1, so I tried right, then I could have gone down, was not possible, I would have gone right, here I could have tried down and down again, and it was possible. So this is about the code of backtracking, and here is where backtracking is happening. Solution x y is 0, I return a false, so it goes back towards the one step of recursion and chooses another path. So I hope it helped to understand you the maze problem, and you have to understand is that it follows recursion and it follows backtracking. So backtracking means what? I had put this in my solution of the path, but after seeing that okay, neither right neither down is possible, I make solution x y false or 0, and I go to one upward level and try another path. So hope you like this video lecture.